Devanbu. What would you like to be able to share, Prem? I think you're already a co-host, or are you going to be using? Okay. Okay.
Yeah. So I don't know if I'm in the spotlight or not, but it's up to you.
Let me go ahead and put you on the spotlight here. There you are. Okay.
Okay, great. Are you seeing the screen now, or seeing the slides?
Yes, we are.
Okay, great. Okay, so this is also about a course that I taught at UC Davis. I wish we had the same kind of success in publications that Abraham did, but we didn't. But anyway, here's what we did. So this is an empirical software engineering course. The motivation was that, like a lot of companies these days, have software assets with both metadata and source code. And we'd like our grad students, the master's students, to have training in how to use this data to do various kinds of hypothesis testing and data mining and so on. This is well known that people have found that in many cases, salient events like defect occurrences have stationary distributions. So if you build models, you can inform and improve software practice. So that was sort of the motivation for teaching a course in empirical software engineering. That we wanted to familiarize people with the whole pipeline, kind of formulate questions of interest, gather data, perform both exploratory data analysis and hypothesis testing, and sort of understand the constraints of how to do both in a disciplined fashion. Okay, so the course started off with a broad overview of empirical methods, like everything from observational studies to quantitative studies, the whole range of things that are available to people to study software empirically. There was also an introduction to open source software development practices for people who are not familiar with it, and kind of the core intuitions and limitations of observational studies, which is what you can do with open source software. And then various tools. The last time I taught it, which was 2019, I used BOA. Next time, I'm definitely going to also teach them PyDriller, which is good for metadata. And various kinds of outcomes that are of interest. Defect studies primarily is our focus, but we did a few other things as well. We have a whole unit on in the course on issues and risks and fallacies in empirical studies. From bias to these types of ecological fallacies, these types of issues that come up when you do empirical studies. We spent a lot of time on the Unidis paper about kinds of things that go wrong when you're doing experimental work. We cover social software development, ecosystem level studies, like what happens when people migrate between projects. And of course, given it's Davis, we also have a unit on naturalness of software. So one of the homeworks, there's just 3 homeworks. So each homework is 2 weeks. It's a fairly major, each homework is fairly major. There's no finals or midterms. It's just the homeworks. So with the goal of, with BOA is that students learn that there's a lot of useful information in large source code corpora that can be extracted and put to good use. They learn the basics of AST querying. So I actually go back and cover the Genoa paper from 1992, which is something I did years ago for querying ASTs. And then we cover a visitor pattern, which surprisingly many of the master's students have not had exposure to it. So we covered that as well. And then we get into BOA. The nice thing about BOA is that it's fairly language independent. So hopefully, if they learn how to query in BOA, they can query in other languages as well. Or, even if there's no querying framework for the language there that they care about, they could probably write something using visitor patterns. Hopefully, they learn the concepts of it. So this can the homework is meant to illustrate how this can be used to cover a wide range of questions relating to source code. Okay, the homework itself is just a few different tasks. So find the number of files in different languages, find out which languages are changing more, which files in, the files in those languages that change more, which languages are involved in more bug fixing commits, find major and minor contributors to each project and how this fraction varies across projects. And also, like, finally, how people use exceptions in the code. So, so this is sort of the homework, and they have about 3 weeks to do this. So there's a quick learning curve they have to climb. So we sort of work that out. So we had like I said, in the class, I have covered a lot of different things like the history of ASD querying, show them a few different examples to illustrate the concepts. And then I teach them a visitor pattern, for example, and then there's a quiz. There's an in-class demo, maybe 20, 30 minutes showing them various examples, doing live coding, so they get a sense of how BOA works. And then we have a evening where we, with me and the TA, we're there for 3-4 hours, with free pizza. It's not a huge class, it's only like 20, 30 students. So to help them get started on the thing and help them out with problems they're having. So at least try to finish the first or second part of the homework, which are fairly easy. So they get an idea of how to use BOA. And then we had plenty of office hours, and an excellent TA who's just graduated and gone to work for Sandia Labs. So he was extremely helpful. So, so that's most of what I had to say about it. Most students completed the homework. It wasn't like a really major challenge what they were doing. I would, pretty much. So it wasn't. Most people were to complete it. It wasn't like they were doing open-ended research. There were some complaints about the documentation, about how they had trouble finding things. I don't remember the full details of what they were complaining about. What I do remember is that in most cases, we'd see the question on the website, and then we'd be able to quickly figure out what the problem was. So I'm definitely very happy with it, and my plan is to use it the next time I teach the course, which will probably be 2022. So yeah, I'm not teaching this course next year. Somebody else is. So when I teach it again, and my plan is to use it. So thank you very much. Take any questions if you have any.
So any questions for Prem and Abram from the audience?
Gregory's got a question in chat, and it's to Prem.
Okay.
Are queries of your exercises on the web?
They're not. I can share it if anybody wants them. Yeah, sure. I mean, if you want them, just drop me a note. I'll send you an email.
Prem, how do you evaluate the students' stuff?
So it's a small class, so it wasn't that hard. It was basically we reviewed everybody's code, by hand. We didn't have any test cases or anything. We just reviewed it by hand.
So another.
By the way, I'm not willing to publicly share the homework. It's it's aggravating to make up homeworks. In fact, my homework is stamped all over with warnings about how the sky is going to fall on you, and you're gonna be in front of a firing squad if you upload this.
But perhaps we can make some example homeworks that.
Yeah, I think that would be good. Yeah.
That others can make use of using BOA. But I think that's a very nice warning, Prem. Maybe we could take that warning and share with the solution and so on.
Well, UC Davis says it's a violation of academic academic misconduct if you upload homeworks without the consent of the instructor. So
Okay.
it's easy. Yeah.
That's good. Other questions for Prem and also Abram and I think Stefano is still here. So any of the three speakers, any other questions? Thank you again for all of your talk today. It was nice to see experiences from the diverse parts of the world to see real uses. I think if we were to spend some time fixing issues, we would like to fix the concerns that you have faced in your courses first. So I very much appreciated hearing from you. Thank you very much. So next goal today is to and I